Welcome to the video lecture as a part of electrical machines. Today I am going to explain open circuit test on single phase transformer. So these are the learning objectives. The main purpose of open circuit test is to calculate the iron losses and predetermine the efficiency of different loads and different power factors, and also to obtain the shunt equivalent circuit parameters of the single phase transformer. The main aim of this test is to perform an open circuit test to determine iron loss of a given transformer. Generally, transformer offers two losses, one is the iron loss and copper losses. By conducting this test, we are calculating the iron losses, and also by using this test we draw the equivalent circuit parameters, especially by using OC test we determine the shunt parameters. So once you know the iron losses, and by using SC test we calculate the copper losses, and also we predetermine the efficiency and regulation curves. Okay, this is the circuit diagram for the open circuit test. This is the transformer. Generally open circuit test is conducted on low voltage side, and HV is open circuit because of in the laboratory LV voltage is available where there is no special arrangements for that. Simply to measuring the losses on open circuit power, we are using the low power factor wattmeter and also one ammeter and voltmeter. So the main purpose of auto transformer is that is a single phase variac. So we are apply the required voltage. Yes, this is the procedure for OC test. As per circuit diagram, connect the circuit and switch on the AC supply and apply rated voltage across LV side of the transformer using an auto transformer, and finally record no load current, voltage and power. So this is the observation table. So under OC test we collected this data, single data, VOC, IOC and WOC. So by using this test data, actually the wattmeter value is called as iron loss. Why? Because secondary is open. Simply under only the iron loss is proportional to voltage. It is independent from the load. So thus even though there is no load, some of the power due to flux reversals loss are occur in the core. So that power is measured by this wattmeter. The wattmeter value generally it is called as V naught I naught cos pi naught, and by using this equation you find out the cos pi naught value. Once you find out the cos pi naught value, IW and IMU values are calculated. Once you calculated the IW and IMU, simply calculate the shunt parameters and R naught and XM by using these formulas. Okay, I want to, this is the equivalent circuit diagram. So this is the diagram. Actually the R equivalent dash value is nothing but by using all the secondary parameters also we can convert it in terms of primary. So overall this is the equivalent circuit of the transformer with respect to primary. So by using this test data we are calculating the R naught and XM. So how it is calculated, these values just I want to explain here. Here please, normally in OC test this is the equivalent circuit diagram of the transformer. This is R01, X01, XM value, this is called as RW. So here I remove the physical transformer and I have to analyze this like this. Here it connected one wattmeter like this, and we provide an ammeter and provide one voltmeter, so like this, and we apply here voltage. So it is a rated voltage under, this is the open circuit, this is called a open circuit. Under open circuit what happened, actually here passing the total current IOC. This IOC is passing through here, this is called as I naught, and remaining current the equivalent current this is the load current with respect to primary I2 dash. But in this branch it is open, so that is why I2 value equal to 0, IT equal to 0. So under no load test or under open circuit the transformer act as only shunt parameters. So overall current IOC is equal to here, IOC is equal to, so no load current branch I naught. Here this current is going to IW, this is called as I mu. So how to calculate the IW and I mu? We already know this is the W naught value, this is called as main, it is connected main side, this is the load side, and this is the common terminal, it is voltage. This wattmeter, it gives the W naught. Here the W naught value is equal to VOC, it is measured the no load current IOC and cos pi naught. So by using this formula we calculate the cos pi naught value. Cos pi naught is equal to W naught by VOC IOC. Cos pi naught is equal to the power by this side. Enter the OC test data, we are calculating the no load power factor. Once you find out the no load power factor, actually here I naught is resolving the two component, resistive component and inductive component. So from that one we are calculating the IW value. Here IW is equal to total I naught into this component cos pi naught power factor, and active component the I mu is equal to I naught sin pi naught, this is equal to reactive component. By using these formulas we calculated the both working current and magnetizing current. So once you calculated, but how to calculate this RW value? So RW value simply, why? Because overall current is passing here, so active power is only consumed in the RW, so that's why we don't require like this. So across this how much voltage is connected, that is called applied voltage. So this voltmeter measures the VOC. So how to calculate the RW now? RW is equal to, yes, VOC by simply what current is passing here, IW. Similarly, what is the XM value? Both are, these are shunt parallelly connected to the applied voltage. So that's why it is also across this branch the voltage is VOC. Here VOC by I mu, we are getting the XM value. So by using this test data we are calculating the shunt parameters of their equivalent circuit and equivalent circuit. Not only that, under OC test there is no any current passing through the winding, secondary winding, and also very little magnetizing current is passing, so that is why that is neglected. So that's why in the OC test the winding loss are neglected, that is the copper loss is nullified. That's why only another actually transformer having two losses, one is the copper loss and another one is the iron losses. So iron losses, the remaining current is passing through the actually magnetizing current due to that flux is set up, that is called as alternating flux. Due to that alternating flux, the eddy current loss and ST loss are happen in the enter the core. So by using this test we are measuring the iron losses. Here W naught, it gives the iron loss of the transformer. So like this transformer. So by using OC test data we are identify the two parameters. One is the iron loss of the transformer, another one is the, by using this test data we calculated the both shunt parameters of the equivalent circuit of single phase transformer, RW and XM. So thank you.